escaping complexity in the world of clean code and OP, or getting job done oriented programming. Now, if you are happy with how mainstream programming is done nowadays and all the best practices that prevail in the industry, you can just safely skip this video. Now, I want to start off with a short story of my programming career. I started working full-time as a programmer in 2010. Before that time I was doing some programming, but mostly as a hobby, and since 2010 it was full-time. At the time I was gaining experience and skills, and I was pretty much happy with how the software was built. Then at around March 2015, I started feeling that I was not as productive anymore as before. The programming was not as joyful experience anymore. Instead of building, I was slamming together all these frameworks and layers upon layers of stuff. It also required me to relearn every 12 months how to do the same job with a new tool and a new framework. So I didn't feel I was solving the real-world problems with this activity. Building software felt too complicated, and I felt that we as the industry were headed in the wrong direction with all this complexity. It was not as joyful anymore, and it felt too complex. This feeling of frustration grew inside of me to a point where at March 2020 I abandoned programming altogether. I started my own company with my co-founder, and I was not doing any programming whatsoever. I was hiring people, doing sales, marketing, management, all this fun stuff that founders have to do. The company is still growing fine till this day, but that's not the point. The main point here is, at March 2022, we decided that as a part of this company, we're gonna create our own software. It was gonna be a SaaS web application that we would offer to our customers. And since the company was doing quite well, I knew that I could dedicate some of my time to programming this project. I knew that I didn't want to end up in the same situation that I had before, where I was required to follow all these best practices in order to keep my job. Right now, since I don't have any employer anymore, or rather I'm my own employer, I can build software the way I want. And I don't have to impress anyone or conform to any formalities from employer or prove anything to anyone. I can just do my job in the best way I can and see what happens. And thanks to some inspiration on the internet, especially Jonathan Blow and Casey Muratori, I saw that if you think for yourself and make your own decisions based on reality and not what the industry is telling you, then there is a possibility to discover better ways of building software. So maybe if I try that, I could find such a way that could be successful and make me productive again. And if it turns out that I'm wrong, so let it be, and I can always come back to best practices that are considered a safe path. So I said to myself that I'm gonna rediscover programming from scratch. I would just write some stupid code that makes the computer do what I need it to do, similarly to what I was doing in school when I was programming as a hobby, and I would trust myself that as the problems arise in the code or in architecture, I will try to solve them with whatever makes sense, without trying to use any principles of OP or whatever else was written in popular books on programming. So I focused my attention to solving actual problems and doing things that computer needs to do. As a result, it turned out to be a success, and now I'm the most productive I ever been and the most happy I ever been with programming. The software doesn't feel as complicated anymore. Of course, it's not perfect, and I'm still on my journey of discovering the most sane way of programming. But it's already way easier and simpler than it was in the past. And today I will try to summarize some of the concepts that I see, looking at how our small team is building software nowadays, the ideas and mindsets that help us make sane decisions in this world of insane software practices. These will be high-level ideas because I find that most of the problems with software is not actually in the coding practice itself, but it's in everything around that. Hopefully some of the ideas listed below can be helpful. Side note, consider these ideas as a seed to grow in your own judgment and not some rules that you have to confirm. There are no hard rules in programming or in life in general. Now, my background. I listed here the projects that I worked on, so it's not an exhaustive list, but it's just to give you an idea where I'm coming from. I started my career working in C++ and building desktop games. I was fired from that place actually, it's probably the most embarrassing part of my career. Game programming is actually quite hard and I was very junior at the time, so I lacked the skills required to do the job. But over time I shifted to web development, I learned some Java. For the next 3 years I was doing some web applications and internet banking systems, started on the front end, then moved to the back end. Then I was doing some Scala for the next 5 years. I built some internal web applications for stock exchanges and integrations between different banking protocols, made backend for some online games where people could play on different platforms online. Then I did scraping with Kotlin and built some bots for the web. Then I built some more web applications with Elixir. And since 2020, I'm building my own company as a founder, and for programming our software I use TypeScript. As you see now, it's mostly web development, so that's where I'm coming from. And the languages themselves do not matter as much. That's actually how long it took me to realize that languages do not matter to the extent that we usually think they do. The first idea that I want to talk about is cost. Pay attention to the cost of everything in software. Every benefit has a cost. Prefer tools with only the benefits that you need. Avoid using benefits that you don't need. Also see Tim Berners-Lee has a great article on the principle of least power. If you don't see the cost, it's still there, you just don't see it. So you will discover it down the road. Example. You can either write code just as a block of code, or you can write it in a function and then call this function. The function has a benefit that you can call it multiple times from different places, but it also has a cost. It has to be abstract now and work for all the cases, whereas a block of code written in place can do only what you need it to do and exactly how you need it to do, and doesn't have to work for all the cases in a general way. There are other concerns, of course, and it's not that one is always better than another, but this is a trivial example that illustrates the point. We as programmers make choices every day, all day, and these choices have all different cost-benefit ratio. Costs and benefits are like building your player profile in the game. Imagine every time you increase strength by 1, your endurance automatically gets decreased by 1. Is it that strength is always better than endurance? Of course no, you pick what you want in your specific circumstance. The problem is that picking the right thing requires you to do this cost-benefit analysis. The next concept is goal achievement. The more goals or priorities you have, the less is the chance of achieving all of them. Example, if you want to become stronger and smarter, then you are less likely to succeed at both of these priorities at the same time. If you were to choose a single priority, then your chances of success are higher. Every additional priority that you have in a company makes other priorities weaker. Don't try to optimize 100% of situations. I optimize for solving important problems, and I can afford suffering some inconvenience with problems that do not matter as much. For example, for iteration I will only use a for loop in the TypeScript example, and I will avoid using map, fold and other functional styles of iteration. Why is that? Because one of my jobs as a programmer is to be able to quickly see all the loops in the code just by glancing at it. And if I know that any loop starts with for keyword, then my brain gets used to that and automatically finds all the loops in code just by glancing at it. So ability to very easily see every loop in the code and see possible performance bottlenecks is more important job than the convenience of writing a concise map or fold. I can even use my code editor to quickly find all the loops in the code. And also if I decide that I want to break out of loop, I can do it. Whereas if I were to use map and then decide I want to break out of it early, I have to change map to something else or throw an exception. And if I need to find all the iterations in the code, I'm not able to do it if I use different ways of iterations all over the place. Also, for loops do not create closures that I don't need as well. All these subtle benefits, they add up and make for loops more versatile in my opinion. Now, as you can see in this example, I will still use map iterations sometimes in very few restricted cases that don't have large impact on the entire flow and are very local. But that's a trade-off that I'm willing to make, and I don't make this choice consciously, it's already happening on the subconscious level. That's what is known as professional intuition. Now, the next thing is solve hard problems first. Solving easy problems is easy. Choose tools that solve hard problems first and trust that you will be able to solve easy problems with any tool. Example of that is rendering some HTML on a page depending on some state is not really a hard problem. I don't need React for that. React makes it nicer to do, but does it help me solve hard problems in software? Let's take a look at some of the hard problems that I care about in a typical web application. Hard problem number 1, making software run fast. Does React help me with optimizing my code for performance? No, it's very hard to optimize React applications, especially once they get big. Hard problem number 2, once the code is fast, keep it fast. Does React help me keeping my code fast and not introduce performance regressions by accident? No, it's very easy to cause a chain of recalculations in React that will cause performance regressions. Hard problem number 3, making software work well for 10 years and maintain it without regressions in quality. React is changing every 12 months, so we have to constantly relearn new ways of doing the same stuff but with different APIs. React is not helping me maintain software for 10 years at all. I have to keep upgrading to newer versions and fix the regressions every time the code is migrated to a newer version of the framework. So if a framework does not let me solve hard problems, but only solves easy problems for me, I try to stay away from that. I try to optimize for solving hard problems as my first priority, and I trust that I can solve easy problems with any tool. Now, people will say that React makes you super productive. Well, there are gazillion ways to be productive that don't involve compromising on performance or predictability of your program. And then, if you take into account the maintenance cost of React application and the time to debug issues and optimize performance and the time to migrate to a different version of React and the fact that you are almost required to have React engineers as a separate role in the team because React requires too much knowledge, so basically if you take into account full cycle cost of software development with React and the impact on the entire company structure, that's not looking as good of a deal now. Now, for some companies, React actually may be a solution to really hard problems. For example, such as how can you make 100,000 programmers work in the same code base and stay productive? Now, that's a really hard problem to solve, and maybe React is a really good solution for that. I don't know. But you have to think if your specific company has this problem or not. The next thing is point of leverage. Any given problem can be solved at different levels. Examples of such levels are coding practices, determining the right problem, and hiring process. You can leverage any level to solve the problem. For any given problem, there is a level where your effort will produce more results. Also, the team must have skills on all the levels. For example, if you struggle identifying what problem needs to be solved, then no matter how well you write the code, you will have a hard time being effective as a programmer. Some solutions require making trade-offs on other levels, such as the React example we talked about before. Let's say, for example, you decided to not use React in your program. Then your hiring process has to change dramatically. Instead of hiring for React skills, you have to hire for problem-solving skills, which are actually harder to find and even harder to evaluate. And if your company is not able to solve this hiring problem, then you are almost destined to stick to the mainstream React way of doing things. Because that's where most of the programmer skills are. So it's a problem that you have to solve on the hiring level, not in the coding level. If you want to avoid React but don't make this trade-off in hiring, then your decision of building without React or similar framework will not work. Another example is Ruby on Rails and their famous convention over configuration, which totally makes sense. The problem that it's solving is configuration in simple systems, and Rails solved it by simple convention and agreeing on defaults. So the problem is solved not with the code at all, but just with convention. The more levels you can utilize in your solutions, the more effective you are as a programmer. That's what I call 10x programmer. People usually call it think outside the box, but that's just too abstract to me. Here's the levels that I use in our team to solve problems. Business model and strategy, hiring process, architecture, deploy process, team organization and how people split work between each other, how people identify the right problem they are solving, how people can focus on what matters at the moment, how people can design a solution, how people can debug problems, and at the end, how people write code. I interview a lot of programmers, and most issues I see in the candidate is not in how they write code, but rather in all the rest of the levels. How they determine what problem they are solving, how they design a solution, etc. A lot of times I see programmers who can write very sophisticated code but are very weak at determining the problem they are solving and designing a solution. If you cannot determine the problem precisely, you cannot solve it precisely and effectively. Now, not every level is available to you, of course, but you still have top management in the company and it's their job to solve all the levels, including hiring and team organization. That's another problem, that it's not only programmer's job, but the company's job as well to execute their part of responsibilities. And me being a CEO, I'm trying to make trade-offs at every level in order to optimize the entire company so that our team can build the best product they can with the resources they have. I started the business model and the company strategy, then I optimize hiring process and all the way down to coding. One example how we optimize hiring process is we do not allow junior developers on a team. Just by doing that one decision in hiring, we already eliminate a lot of issues in coding. Another example is Twitter. Twitter is solving spam problems in DMs by requiring premium subscription. If you want to send a DM to someone who does not follow you, Twitter requires you to have a premium subscription. Whether you like this solution or not, that's not the point. The point is, it's a great example of solving problem at the level of business model, and it's a very effective and requires less effort from the Twitter engineering team compared to previous solutions of trying to analyze all the DMs in the entire system. Side note, the more levels you can have in one head, the better you can optimize your decisions, making trade-offs at any level you want. Of course, the bigger the company is, the harder it is to have all the levels in one head. And side note number 2, if you are not making trade-offs, then you don't really have priorities. Jobs to be done. This is the framework that lets companies look at products they are making from a different angle. It's like a mindset. Instead of thinking what features we have to build, we are thinking what job our product is solving. So we are trying to optimize the product to solve this job better and better. Example, McDonald's milkshake is solving the job of satisfying hunger on commute. When McDonald's determined precisely what job their milkshake is solving, they now can optimize solving this specific job. So every product has jobs that it's solving. Now, when we have all these concepts in mind, that's how I see software development process. I try to solve as few jobs as possible, but pick the most important ones and use all the company levels to optimize for solving these specific jobs. The ideal situation is having only 2 priorities. Priority number 1, get user jobs done. The software has to solve problems and satisfy needs of the user, run fast, work as expected, not require too much time to learn how to use it, and not change too frequently. Basically, not force users to learn new UI if it doesn't bring new value to them. And priority number 2, get programmers jobs done. The programmer has to write code, deploy it, run it, identify issues and fix them quickly, change code according to new requirements as we discover them, and make the code understandable for other team members. And we want to do all of this and make sure that the value created for users is greater than the value invested into building the product, so that we can capture some of that value and have a sustainable business that lets us keep building the product in the future. Now, let's look at that from a different angle a little bit. There is this concept optimizing from point A to point B. Let's say we have a point A, which is we don't have any product yet, and our point B will be making a first version of the product that users can use. Or it can be point A, for example, we have version 1 of the product and we want to go to point B, which is version 2 of the product. In ideal situation, we want to go from A to B in the most straightforward line we can. The reality is that we have some essential complexity that exists in the domain of the problem and we cannot escape it. So essential complexity looks like this squiggly line from A to B. Example of such essential complexity, for example, in our company, our product that we are building is using Amazon retail and advertising APIs, and build some UI on top of that to provide users with analytics and give them some tools to take action on this data and improve their business as a seller on Amazon. Now, since Amazon API has some inconsistencies and different parts of API have different versions that evolve and we have to migrate between them, this is essential complexity to us and we cannot escape it. Then additionally to our essential complexity, we have to solve the jobs that need to be solved for users to use the product and get value out of it, and for programmers to be able to maintain the product and keep developing it in the future. So if we add these 2 priorities to already existing essential complexity, now our line is even more squiggly, and that's our most efficient way in going from A to B, and we try to follow that. Now, the problem is that mainstream way of building software is something a little bit more complicated like this, where we have everything we mentioned above plus some made up additional complexity. Examples of such complexity are solid principles. Now, I don't have anything against every specific principle in itself, but the whole point of trying to apply these principles as much as possible doesn't make sense. I would argue that they are not usually solving the hardest problems in software. The same thing is layers. Examples of that are 3-layered architecture or onion architecture or whatever architecture. That's also not the best way of solving problems, because it doesn't take into account any specific knowledge about your specific domain and the specific program you are trying to build. Layers can be fine if you end up with them, but you should not try to create layers up front without solving hard problems with these layers. In my experience, most programs need way less layers than they actually have. The next thing is libraries and frameworks. I don't have problems with libraries as a thing. The problem is not with the libraries themselves. The problem happens when the programmer decides to use a library where it doesn't strike a good cost-benefit ratio. Every additional dependency adds a weight to the project. Now you as a programmer have additional job to do. You need to upgrade to newer version of library, read migration guide and fix all the regressions when they happen. And keep learning new tutorials, new materials, new news and documentations when the framework is growing and developing. Now, if you consider your work seriously and want your project, for example, to work 10 years or more, then on this timeline, any open source library or framework can die. And when it happens, you got additional job to do. Either fork the project and become a maintainer of codebase that you didn't write and may not necessarily agree with the decisions that were made in the codebase, or replace this dependency with another alternative if it's possible, and fix regressions as they inevitably come up. Libraries and frameworks don't have any knowledge of your specific application, domain, or requirements. Those you cannot leverage any trade-offs that are allowed in your case, but couldn't be anticipated by the creator of the library. Another example is OOP, Object-Oriented Programming. I don't have any problems with objects themselves, but orienting the entire program around objects, that's the issue. You don't want to orient your program around anything else except solving the jobs that need to be solved. The next thing is the need to feel emotional comfort. There is a need in programmers to feel that everything is nice and the code is beautiful and not dirty. These concepts do not exist in real life. They only exist in programmer's mind and just make programmer more comfortable. So trying to solve emotional comfort is just introducing additional friction in your path from A to B. This can be very subtle. For example, a solution that you apply seems to be solving the problem you have, but the solution is not as directly and precisely focused on the problem as it could be. But it's a little sideways to make the program feel emotionally comfortable and make code look nicer. Whereas a direct and precise solution will be the most effective, but it will not provide such a comfort to programmer. So you have to learn to get rid of this need of feeling comfortable. The next thing is trying to look smart. In the past, I was required to use some complex tools that are used by Googles and Facebooks of this world. I thought that these companies were considered smart and I wanted to prove that I was also smart. So I'm gonna do the same stuff that they do. But these companies have different problems and priorities and you may not necessarily have the same problems in your company. So all of the above complexity can be summarized as solving problems that you don't have. The more precisely you can identify the exact problem you are trying to solve, the more effective your solution will be. And if on top of that you are not trying to solve problems that don't exist in your company, you're gonna be the most effective. Also see Mike Acton has a good talk on problem solving. So, in summary, understand your priorities and have as few of them as possible. Solve exactly and precisely the problems that you have. Do not try to solve some other problem that you don't have. Optimize at all levels in the company. Pay attention to the cost. Everything has a cost, and there is no benefit without the cost. Your job is to build products that get user jobs done, and in the meantime allows programmers to get their job done. All of this is about your judgment and how you make trade-offs. It has very little to do with actual coding practice. You are a problem solver first, and it just happens so that you solve problems by means of making software. Do not delegate your judgment to someone else. Make up your own mind from your own experience. Thank you.